Welcome back from the networking break, and there are still plenty of great sessions lined up on this final day of Technology, AI and Cyber Live. And case in point, next up, we have Carrie Bimaya, CTIO of Capgemini Invent. Now, Carrie's role is to define the business and sectorial implications of emerging technologies that are of strategic importance to Capgemini Invent, inform go-to-market implementation plans, aid in the creation of new client-specific solutions and services, and contribute to thought leadership on innovative technologies. He is also a member of Capgemini Group's Technology, Innovation and Ventures Council, which sets the technology strategy and investment agenda for the company. Now, prior to joining Capgemini Invent, he was Director of Research at an AI startup and an economic researcher for the EU Horizon 2020 project. He's also the author of The Blockchain Alternative and has given 2 TEDx talks on the effect of decentralized technologies on capitalism. And an interesting fact, in a previous life, he was a legionnaire in the French Foreign Legion, no less, and was awarded the Cross of Valor for combat operations in Afghanistan. So, welcome, Carrie.
Thank you so much for that introduction.
You're very welcome, and I'm really looking forward to this session. I know you've got lots of insight to get through, so without further ado, I'll hand straight over to you.
Thank you so much again for that introduction and for this opportunity to be speaking at BizClick. This presentation is really something which is going to be a bit counterintuitive to some people, but it talks about what is actually happening in terms of the effective technology and business strategy. I work at Capgemini Invent, and Capgemini Invent's role is to focus on the new and next. When we say the next, we're talking about the next generations of solutions that we're creating using emerging technology. And when we talk about new, we're talking about the new kinds of solutions that we can create today, again, thanks to emerging technology. Now, technology and business have always been 2 sides of the same coin. But what I'm going to show you today is this paradigm is actually changing. It's changing quite dramatically. And as a result, it's going to impact the way that we think about business strategy moving forward in a very different way. So it's always good to start any kind of a story with a bit of a historical background. And in this case, I'd really like to go back to the 14th century when there were 2 key technologies which had a big impact on the way that the world works today. The first was gunpowder, and the second was the printing press. Now think about it. If you were to go to Germany in, let's say, 1455, and ask some random person who's just walking down the street, do you think that the printing press is going to create the effects of undermining the authority of the church? It's going to trigger the Protestant Reformation, create something called modern science, lead to the creation of things which have never existed before, new industries, new jobs, and even new identities, if I may say so. And it's going to change our entire conception of how society works today. The probable answer that you would have got from these people is, you're probably a bit crazy. But nevertheless, it's exactly what happened. When gunpowder came into the scene, it was able to scale war to a totally different level. It turned out that in order to be able to buy gunpowder, you needed a lot of money in order to do so. And so the monarchs at that time started giving out licenses which allowed the creation of the trader or the merchant class. At the same time, you had the printing press, which really democratized information. If you fast forward not too far forward from that time, these 2 effects actually were the first things which led to the fragmentation of society. Previously, you had the church, you had the monarchs, and then you had, everyone else. But thanks to these 2 technologies, you had the creation of the merchant class. And if you fast forward all the way down to the industrial era, that fragmentation effect became more and more prevalent. Today, it's 2 different technologies which are doing this, but the outcome is the same. And if we were to think about, how does this actually happen? Well, it turns out that it's quite easy to actually predict the impact of how technology is going to affect a society if you follow this kind of a curvy path actually that gets created. So the person who actually came up with this the first time is Kevin Kelly, who is the founder of Wired Magazine and the author of over a dozen books on the impact of technology and technological evolution. And Kevin actually realized that every time a new technology is created, it goes through an evolutionary path. It starts off with being something very, very specialized. It's made for a very specific purpose. But then As it starts getting improved upon and being used, other people try to kind of copy paste it and use it in their own areas or for their own problems. So it creates a bit of diversity. As this diversity increases in different sectors and in different industries, it starts becoming very ubiquitous. You start seeing it everywhere. And that's when it starts becoming very, very social. Once it reaches the socialization phase, it becomes something which is very complex, to the point that at one point of time, you don't even see it anymore. It becomes almost invisible. A good example of this is electricity. It started off as something very specialized, but today, you use it everywhere. The final point that to say about how this technological evolution happens is also the fact that it's not just about capitalistic or technological change. It's also about social change. And this is something which Ursula Le Guin was able to say the best way. She said, technology is a carrier bag of culture. While this framework is a bit abstract, and since we are talking at a conference on technology and AI, I thought I'd use the example of computation to kind of showcase this evolutionary path. When the first computers were invented, they were made for something very specific. They were made to calculate the trajectories of shells. This was done with the differential analyzer with Vannevar Bush. And as World War II broke out, the computation and the differential analyzer was adapted to cryptography by people like Alan Turing and Max Newman. It also led to the creation of the EDVAC. And once that actually happened, it led to the creation of the first binary computer post the Second World War. As the first binary computers were created, it started becoming more and more ubiquitous. It was no longer being used just to trace the trajectories of shells. They wanted to be able to do more things with it. Punch cards were replaced by programming languages like Fortran and COBOL. And of course, the rest, as different functionalities came, different languages evolved as well. It's because of these three changes on the evolution of computation that we were able to create the first distributed networks. We're talking about ARPANET, which led to the internet, which led to the World Wide Web. And once computation became something very social, it then started becoming very complex. We started using it to computerize pretty much any task that we do today. It led to the acceleration of artificial intelligence and, dare I say it, even TikTok. So today, if you look at computation and artificial intelligence, it's become a general purpose technology. It's something that is used in almost every value chain or in every area, whether you know it or not. And this is where it becomes even more interesting, because as technology kind of goes through this evolutionary path, when it reaches this point of being something which is very used in pretty much every place, it leads to the creation of a higher order system, because technology has a tendency to feed off other technologies. One of the people who was able to really explain what is the outcome of this evolutionary path and how does it actually impact business was Simon Wardley. Around a decade or so back, Wardley came up with something which is called the Wardley mapping method. And what he was trying to do was actually take the value chain of any business and see how these different technologies actually are in the different components of the value chain. He came up with a very visual map, and it's the reason I'm a fan of this as well, because if you're going to be doing something, it's always better to be able to visualize it in order to kind of figure out which direction you need to go to or which direction you don't want to go to. And when he was kind of building these Wardley maps, he also realized that every time a technology kind of improves or it evolves, it goes from being something which is what he calls genesis to something that becomes a commodity bit by bit. So this is very relevant to the same way that Kevin Kelly talks about it, except it's got an X and a Y axis this time. One example of this is what you see today in terms of how we run our websites and how we actually do a lot of online businesses. Before you had your recommendation and your website, which was essentially a product, you had these monolithic architectures where all of these different components of this value chain, or digital value chain, were built in-house. It was expensive to maintain. It was really, really hard for it to kind of evolve. But as technology improved and we went further down towards commoditization, thanks to technological evolution, you see a change in the way that the value chain actually looks like. You move from being things which are, custom built or products that you buy off the shelf to increasingly becoming commodities. And this is a key point to kind of understand, because it's when they become commodities that they get used by a large number of people, and people start thinking about using it in different ways. And that leads to the creation of these higher order systems, which you're going to see in a bit. The key point to understand over here is tech combines in order to create new technologies powered by economic incentives, that decentralization and fragmentation are the outputs of this evolution, and that this kind of volatility and entropy, which you're constantly seeing in any kind of economic system, is the actual state of the economy. We've been educated to think that any economy works in some kind of equilibrium. You have efficient markets hypothesis, you've got rational expectations theory, you've even got dynamic stochastic general equilibrium models, which are used to make monetary and fiscal policy today. But the premise of all of that, I would say, is a bit flawed, because the natural state of the economy is one that is entropic and not that of equilibrium. Since we're talking about technology, you always have to talk about the capital that allows it to actually get created. And this is where two giants in terms of business strategy enter. The first is Bruce Henderson, who was the founder of BCG. And then you've got Michael Porter. I think everyone knows who he is. These two guys were able to really figure out what was actually going on in terms of technology and business strategy, because they were able to focus on something which is very key, which is transaction cost. What Henderson and Porter were able to figure out was that in any company, the efficiency of the company is based on the efficiency in which you're able to pass on information and the cost it takes in terms of communicating this information at different strata of the company. This is the primary reason that we have these pyramid-shaped companies today. The reason that you have these pyramid-shaped companies is because there's so much information that's happening around the market that you need some way to take that throughput of information, pass it upwards, and then have decisions make it come down. While this kind of like de facto way of working has been prevalent for the past, let's say, 100 odd years, which is not a long time, by the way, what we're seeing today is that's actually getting impacted more and more, and this fragmentation effect is increasing because of the fact that technology's evolved to a different state and that there's too much information right now in the economies and the businesses in which we work. We always start with process because it's based on people, and that's how you create a new kind of a product. And the reason that I want to focus a little bit on the people aspect is because the reason we make different changes in terms of technology and being able to kind of, have these new value chains in our company is because we are transactional as a species. We are constantly trying to figure out how do we make something better. And this human aspect is extremely important because it influences the way that we think about how our companies are going to get created and how we generate value. But the summary of this first part of the presentation is essentially that today, while mechanistic hierarchical structures were the predominant way in which businesses and business strategy was created before, today the changes are occurring which is making decentralization and fragmentation the de facto architecture through which we can actually evolve and move forward and leverage the effects of technology. So with that kind of a historical understanding and the theory behind it, I think it's important for us to kind of see how this transcends into the current context. And over here, I think the best way to start it is by just listening to a quick video on the subject of TinyML, because it showcases how cloud and AI, which is used in every business today, is itself getting fragmented through a new technology. To showcase that, we're going to have a short video, which is going to be done by the chief scientist of ARM and Qualcomm.
Here with me today is Dr. Evgeny Gusev, who is one of the leaders of Qualcomm's AI machine learning labs. He's also a member of the board of directors at the TinyML Foundation. Evgeny, machine learning is a thing that I think many people are kind of familiar with. When they think of machine learning, they typically think of big compute, big data centers, massive training jobs. But TinyML is really something quite different. Can you explain?
Oh, yes, Steve. The difference between the TinyML and cloud-based ML, which is a traditional ML, is really fundamental. And unlike the cloud-based ML, TinyML enables machine intelligence at the very edge of the physical and digital world. As a result, resources like compute, memory are quite sparse there. So to be able to do machine learning under this type of condition is quite challenging from a technological perspective. You need to innovate in the hardware system, algorithms, all those areas. And typically these devices operated like 1 milliwatt type of power, which is actually quite impressive and quite challenging from a technical perspective. And that creates a very unique advantage to end users because it offers quite unique latency advantages, power advantages, obviously, and and the privacy advantages. And it's one example. I can show the technology we develop and commercialize at Qualcomm. So this tiny piece of silicon, it's a dedicated engine that does tiny ML at this extreme low power, 1 milliwatt type of regime, battery operated devices, obviously. And it does full vision-based analytics in always on fashion in this tiny kind of size of the grain of rice type of.
So what that video really shows us is how this fragmentation effect is actually moving forward. And to come back to what we've been talking about till now, where TinyML actually sits down is in the fragmentation, obviously, of cloud and AI. We are seeing it's made by the convergence of machine learning and deep learning, task-specific hardware, and of course, edge computing. But more importantly, if you take a step back, it fits into a larger technological context. You've got artificial intelligence and cloud computing, which are already two sides of the same coin. And now you've got task-specific hardware, 5G networking, TinyML, everything inside over there, which is leading to the creation and acceleration of different types of technologies, such as augmented reality or virtual reality. These changes are not just something that's happening for the sake of it happening. Today, we have a lot of inefficiency. If you're trying to do machine learning and you're constantly using the cloud to do your computation, it turns out it's a pretty expensive affair. One example of this is when you're trying to do, let's say, machine learning on data that's coming from sensors. We don't use 99% of that data because it's just too expensive to ping pong it to the cloud, do the computation, and then make the changes over here. When you have TinyML, it really changes the game over here, because now if you really want to be able to do, scale to trillions of devices which are always connected, you can do so at a very low cost. More importantly, it doesn't take a lot of memory, which means that it's actually useful for using it in different kinds of areas which we haven't even thought about today. Talking about cost, and because technology is related to cost as well, it's important for us to understand the cost structure and especially the environment cost that comes into using artificial intelligence. I'm sure a lot of you have heard about, GPT-3 and all these other new kinds of massive models which are coming out there. But what they often don't report is the fact that it's very expensive. GPT-3, for example, has got a $1 billion supercomputer behind it. Plus, it took around, by most estimates, around 10 million just to train the primary model. Forget about the operating cost. And if we look on the side of what this has in terms of environmental impact, a large AI model, the environmental impact of it is probably 30 times the amount that you and I are going to have over our entire lifetimes. So again, when you have technological evolution, it leads to the creation of higher order systems. And the higher order system that we're seeing today is actually in the field of green AI. Green AI is one of those areas which is really erupting right now. And what we're trying to do over here is use these technological innovations to address the sustainability challenge, but from a much more granular level. It comes back to what we mentioned in the first part, the what, where, and how. Today, green AI really affects what you compute, where you compute, and how you're going to do the computation. And these things are very important because it means that you have to have advances in multiple areas. There is a whole new field of study in terms of network pruning, data reuse, in-memory compute, and putting this all together, which is really changing the way that we think about AI and how computation can be made much more environmentally friendly. More importantly, it also changes the way that it creates different kinds of consumer trends. During COVID, one of the things that happened was we were all stuck in our houses. We couldn't go out anywhere. And one of the companies that was able to kind of leverage this rather bad situation was Fortnite. They hosted an entire event which had around 12 million viewers, in which they made an AR, VR kind of experience on their platform. And they even had Travis Scott, relatively well-known rapper, who came up and gave this musical concert over there. So now you see how all these different technologies kind of like come together and improve upon each other to create completely new business models and completely new experiences. And you can do this in your own companies. Look at the specific technology that you're focusing on. Look at the emerging technologies that are coming. And you will always find the same thing. You will find one technology feeding off the other, just like synthetic biology is getting affected by natural language processing today. And you can also see it happening in technologies which are by themselves emergent, like quantum computation, where we're seeing more and more research happening in quantum machine learning, because you need to be able to offset some of the computation with traditional machine learning and quantum computation as well. While all of this is really interesting, there is an important need in order for us to figure out, well, where are we going with this? And this future direction is something which is using another technology, which is by itself made up of a number of different fragments. That technology is actually going to be going to create the paradigm of what we call the metaverse. And the metaverse, I think one of the best explanations is actually given by Kevin Kelly, in which he calls it a mirror world. What we're having today is there's so much information and there's so much technology that we can actually use that to create a replica of the actual physical world. And that has its own advantages as well as its own questions. One area that we see this happening today is obviously with the blockchain. While most of us still have the idea of thinking about the blockchain in terms of like Bitcoin or Ethereum, over the past 2 or 3 years, we've seen the emergence of what we call third generation blockchains like Cardano and Algorand and Solana. These blockchains work on different protocols, proof of stake or proof of history. But what they're also doing is they're creating a new tech stack which is very, very resemblant of the internet tech stack, but it's been made at a frighteningly fast pace. We're talking about like within the last 5 years. NFTs, for example, are just a manifestation of what is able to be created through that. And today what we're seeing is we already had, artificial intelligence and cloud computing and all the technologies which are allowing TinyML to be created, but this keeps growing. Now you've got quantum computation, you've got AR, VR, and you've got DLT. And not only are they all kind of like emerging based on top of each other, they interoperate between themselves as well. This kind of evolution is now creating what we call the Web3. And the Web3 is premised on the fact that everything needs to be interoperable. Irrespective of which chain you come from or which kind of solution you've got to be able to interoperate between them and build bridges. You've got now oracles as well, which have come into the picture, which allow you to connect on-chain data to off-chain data. And together, you then use this information in order to be able to create a completely new kind of understanding of the economy. As we mentioned a little bit before, the natural state of economy is one of entropy. And the people who are building blockchain understand this because they're constantly seeing the entropy in the markets in which they trade and what they're actually trying to, put out there. This is actually helping us move away from traditional economic structures and move more towards complexity science and complexity economics. And two companies which are actually doing this in a very interesting way are Gauntlet and Gyroscope. Gauntlet is a company that focuses on being able to visualize and simulate all the information that happens in all these blockchain ecosystems, whereas Gyroscope is creating what they call an all-weather stablecoin, which will help not just central banks, but other investors as well to use these kind of technologies to go forward and really push Web3 into another level. I'm going to end this part by giving another example. So tomorrow, there's going to be a release of a new game, a new blockchain-based game called Star Atlas. Star Atlas is a AAA grade game. So it's got that cinematography kind of experience. It's very cinematic. It's based on the blockchain. It's already connected to a decentralized exchange where the NFTs and the assets that you can make can now be exchanged between people. And not only are you creating an NFT, they've also added AR to it. So the little video that you see on the side is actually from my phone. I was playing around with this yesterday, and they've already built this. The company is less than a year old, and they're launching it tomorrow. And not only will they be able to kind of like create create these NFTs, they give decision-making power in terms of how this platform needs to evolve directly to the users so that they can create their own products and their own, artifacts and then trade that with other people. All of this comes down to something which we call today, or at least Tiago Forte calls it, the full stack entrepreneur. What we're seeing because of this fragmentation is not just the breaking down of, these mechanistic hierarchies and pyramid structures that we've seen before. We're also seeing the fact that as an individual, you have a lot more independence. Remember that the pyramid structure organization has only been around for like around 100 years or so. So we're actually using technology today to go back to the level of independence that we had before the industrial era. I would also say that in certain ways, the information age is probably going to be more revolutionary than the industrial age was. The metaverse is just one manifestation of it. but you can look at it in any sector and you can judge it by any KPI you want. You will always find more and more independence happening, and it's all based on technological fragmentation. This brings us to the very end of our presentation in terms of like, well, what do you do with this now? How are you supposed to use this in terms of figuring out your business strategy moving forward? And for that, I've got like a few principles and a couple of recommendations. On one side, it's very important for us to kind of assimilate that this is the way that things are moving forward. So the first principle that I would state is, please remember that technology has a tendency to feed off technology. They always work like that. In academic terms, this is actually known as the combinatorial theory of technological evolution. This feeding off of technology leads to the fragmentation of any value chain, irrespective of which sector your business is based in. And number three, it leads to us having a fundamental shift in our mindset. We need to understand that technology is what determines your tactics today and not the other way around. And the reason for that is the pace of technology is increasing so fast that if you ignore that, well, you're going to have a little bit of trouble moving forward. Lastly, fragmentation, decentralization, and entropy are the natural states of the economy. And if you can get this, if you can assimilate this, it really helps you move forward. In terms of what you should be doing to move forward, I'd start by saying that always start with human resources. If you're going to be trying to adapt to this kind of a system, you need to take into consideration incentive structures. And this needs to start. It needs to be a starting point. The second point is you need to use Ashby's law. And Ashby's law, to vulgarize it, is essentially saying that any system that needs to adapt to an environment, the best chance that it has of doing that is if it represents the same complexity as the environment in which it's immersed in. If you're working in a fragmented environment, well, then you need to have a fragmented structure in order to be able to adapt to that. The third point, and yes, it's a repetition, but it's worth repeating, is technology determines tactics. And once you've got your strategy and tactic trees, now you need to kind of encode this leadership in order to keep up with the pace of technological evolution and showcase this to the environment so that you come back full circle and repeat this process of starting with the incentive structures and repeating it again. I'm going to end with this last slide in which I say that we are living in a new kind of an era which is based on technological fragmentation. For us to be able to move forward, we have to actually leverage it rather than fight against it. And once we are able to do it, which is going to happen naturally because it's already occurring in different areas, it gives us a better chance of survival and prosperity in this fragmented era in which we live in. I'm going to end my presentation with that. I hope you found it useful. My name is Kari Bhimaya, and I'm the CTIO of Capgemini Invent. Thank you.
That was brilliant, Kari. Thank you very much. I've got millions of questions in my head, but unfortunately, we don't have time for those right now. Yeah. But I will say that if anybody wants to reach out to Kari, they can do so by networking within the app and within the platform here. So prepare to be inundated with questions, Kari, I would imagine.
No problem. I'm easily findable on LinkedIn. So yeah, go ahead.
And easily findable on LinkedIn too. So yeah, thank you, Kari. It's a brilliant presentation. Really enjoyed it. And thank you for joining us today.
Thank you.
Okay, everyone, there's just about a minute or so before the next session. I'm just going off for a quick game of Star Atlas, but you stay around and watch some of the messages from some of our sponsors, and we'll be right back.